Hello! This video is the first episode of a series of videos in which I will cover the building process of two CNC tables. Both units will be built as CNC plasma tables, while the second and bigger unit will later potentially also be used for CNC milling. The first video covers a good chunk of the work on both tables. Over the past 5 years, I have produced more than 40 episodes of what I call the Scrapyard Repair-A-Thon. In these videos, I performed tons of repairs and also built and modified lots of things with parts that I had found, often on scrapyards, but also thrift stores and online marketplaces. While I have covered hundreds of small and medium-sized objects at this point, I have also quietly collected all kinds of parts and materials over the years that were meant for greater projects. And after repairing a plasma cutter and building a powerful air compressor for it in the last episode, the day has finally come to put all the pieces together and tackle some of these projects that are basically 5 years in the making. So let's have a look at the parts that I'm talking about. So one day in 2019 I had driven to one of the scrapyards I visit regularly, and a local company had just dumped a huge pile of rare stuff. Covered by lots of shavings, I found, among other things, these massive steel tubes and other stock, and also 2 identical linear guide assemblies weighing around 50 kilograms each. I actually bought more stuff from that pile that day, and some of that has already been covered in past episodes. But the massive steel tubes were just put in storage, and the linear guides were cleaned, and they turned out to be in fantastic condition. The idea to build a CNC table of some sort was born. A year later or so, I bought these massive steel girders for a good price from a friend and hauled them off to my workshop. Another scrapyard find then was this huge ball screw here. I actually contacted the manufacturer and they told me that they made this for a Korean customer. I don't know what they would have paid for it, but I found a price for a similar screw from the same company and the price is truly eye-watering. The ball screw seems to be in great condition as well. And then more recently on our road trip that I will cover in a different episode, I bought this gigantic linear guide to go along with that ball screw. The guide itself weighs 100 kilograms, by the way. And then on top of it, I was able to purchase these used window grates here that we might be able to reuse for the plasma tables as well. And at a more recent trip to one of the scrapyards, I then found these massive bolts here. Another time, I found tons of these galvanized steel shelves here that will play a role later on here as well. And there are many more parts that will come together here, but one rather important recent score was this XYZ guide assembly that I bought for $130 including shipping. I will use these parts to build 2 different systems because I want to be able to compare different approaches. The first table is purely for CNC plasma cutting and it will be rather small and light. The second table will be really heavy and will work very differently. It will double as a workbench and might later also be used for CNC milling. And I had to start by preparing many of the large steel parts I had collected over the years, and much of the work was similar and required the same tools and methods. And that's why I started to build both systems alongside each other, as you will see in this video. So let's go to work then. These 10 by 10 centimeter steel girders looked like new when I hauled them home from a scrapyard a few years ago. I'm pretty sure that they were basically fresh from the steel mill. They must have been offcuts left over from some construction project. Since then they have collected some rust, of course, and I wish I had had the space to store them inside instead. But that didn't happen, so I started to brush them off with a wire brush all around. Next, I filled this old plastic barrel with some fresh water and poured in several kilograms of citric acid and stirred the water for a few minutes. Now I was able to place the steel beams inside and let them sit for a while. The duration necessary depends on the amount of rust, the concentration of the acid, as well as the temperature. In this case, since it was rather warm outside, it took only half a day or so to remove almost all of the rust. And since these sections are longer than the drum is deep, I had to flip them upside down and repeat the process. So a day later or so, just a little bit of rust remains in the middle where the acid never touched the steel. We're going to wire wheel that off once the beams are cut to length. The steel tubes I had bought back in 2019 were retrieved from storage and received exactly the same treatment like the steel beams, and in this case it worked even better since they hadn't been stored out in the open. I remember that back then I was thinking about building a big support for the linear guides I had found the same day, but for that purpose they wouldn't have been long enough. But they are just the right size for that XYZ assembly that I bought only recently, as you can see here. I simply placed some parts loosely on the ground here to check if this would all work out. But where did this part come from anyway? Well, it is a used mechanism that came from a machine that is made and sold by the German company D-Prack. It consists solely of guides and bearings, without any motors. The motors you can see here on one side were added by myself, but more about that in just a minute. But in order to build an actual table, the tubes needed to be cut to length, of course, and I do this employing low-tech methods that I've been using for many years. Measurements are taken, and an angle is used to mark the tubes with a steel scribe, before the cuts are then eventually made with a small angle grinder. Using this method, it is necessary to make several cuts from at least two sides, to get a straight and clean result, that is. It might still be just time for me to get a proper steel saw next, once I'm done with all these current projects. In the next step, I first welded the frame that this XYZ mechanism will sit on. It's important that it's level, and it would also be nice to have straight 90-degree angles in all corners. An angle is used to constantly check for warpage or misalignment, and the parts are tacked all around before everything is welded together permanently. I chose not to do any miter cuts and leave two of the tubes open in the front here, and this way I can lead the wires for the stepper motors through the tubes later. In the next step, 4 tube sections are added as legs. It is rather hard to attach freestanding legs to an existing frame without causing warpage during the welding process though. At this point, the legs are only connected to the frame with small tag welds, and in my experience, it is easier to force them into the correct alignment when they are actually held in place on the bottom side of the table as well. Therefore, 4 L-shaped steel profiles are welded in between the 4 legs in the next step then. They will hold the legs in place during welding, but their main purpose will be another one eventually. They will hold a water pan or basin that will catch the sparks caused by the plasma cutter. This water pan will only be installed much later in the process though. Right now, the job was to properly weld everything together and let the frame cool down, until it could eventually be flipped over. In the next step, 2 of the old window well grates from the scrap are cut so that they will fit inside the frame formed by the tubes. And there needs to be a gap to each side as well, since I will probably eventually introduce plastic spacers between the frame and the grates to electrically insulate these parts from one another. We will still have to see if that really will be necessary. These grates were once completely galvanized, just like the ones you see here, which are just somewhat newer. But the zinc on our grates has since been eaten away. But I chose them on purpose because I think that this is actually an advantage here. I don't want to have toxic zinc oxide all over my workshop. And after doing that, some pieces of flat steel were prepared and cut to length before they were then welded to the bottom of the frame. And after finishing that job, the grates are placed into the frame, and as you can see here, the grates do currently not align with the top of the frame. Well, because I need to leave some space for these insulators I want to make to be introduced later. And even if I choose not to install them, I might have to weld little triangles onto these grates, on top of which the workpieces will actually sit, because this way the plasma cutter will just cut to some degree through the top side of these grates. The grates are also not fastened, since they might later be replaced altogether. And now it was time to actually place the guide rail assembly onto the table for the first time, so that I could mark the spots for the holes needed to connect both parts together. The holes are then drilled with the old Metabo power drill, by the way, that we found in the very first episode of the Scrapyard Repair-A-Thon. What a simple and trusty piece of equipment. And once I had used these bolts here to connect the assembly to the frame, I simply wanted to try if I could use this contraption in, well, aiding me to simply make a straight cut through a piece of steel with a plasma cutter we repaired in the last episode. In contrast to the bigger and heavier table, this unit will not use screws at all. It's a completely different approach, and it's supposed to be light and agile, and will be based on tooth belts. In this case, GT2 belts, similar to the ones used in 3D printers. There are many different styles and sizes of tooth belts and pulleys, and we will get a little deeper into that in the next episode. I would have liked to use bigger, more rugged belts here, but the price for a GT2 is simply unbeatable, simply because parts like these are super cheap and abundant because of the mass production of 3D printers in recent years. And speaking of 3D printers, mine came in really handy here. See, when you look at the original picture from the online listing, you can see that there were no motors connected to the guide rails at all. And you can say about 3D printers whatever you want, but they are extremely useful when it comes to making adapter pieces for when you need to connect a part to some irregular or otherwise unusual surface. And this is what I did here. I was able to purchase a number of NEMA 23 stepper motors for a reasonable price, and I also found pulleys for 10mm wide GT2 belts. Using Fusion 360 and a 3D printer, I made a bunch of adapters. This part, which I printed out 4 times, wraps around one of the legs of the assembly very tightly, but it can then also be tightened further with the little bolts on its side. This flange here then connects to a stepper motor with a pulley installed on the motor shaft. It can now be bolted to the assembly. These parts were later further stabilized with a number of wedges that I glued to them, by the way. And this happened with all 4 legs. It would have been possible to just use one motor and an idler pulley on the opposite end, but I got better results with 2 steppers running in parallel here. This part here was printed twice, and it connects to the side of the Y-axis and is bolted in place using a simple backplate. 2 belt sections had already been cut to the exact same length, and they were now wrapped around the 2 pulleys, and both ends were then connected to the Y-axis part by clamping them down under tension. These clamping parts also have a GT2 pattern inside, so that the belt cannot slip. So after installing these parts on both the right and left hand side of the Y-axis, I wanted to know how the system would perform while actually plasma cutting. But I couldn't perform a test as long as I still had to trigger the plasma cutter manually by pushing the button on the handpiece. As you can see, it really is just a simple metal contact that leads inside the device via the hose package. We needed to add a remote control feature to the plasma cutter. On the back side, you find this jack here that acts as an interlock. The machine can be disabled remotely or by simply pulling out the plug that came with it. And this plug, as you can see now that it's opened, only forms the connection between 2 pins. But since I wasn't able to confirm the exact pin out of this connector, I had then simply added 2 black 4mm jacks to the back side of the enclosure. They simply connect to these pins here, which also connect to the button on the handpiece. It would now be possible to trigger the plasma cutter by connecting these 2 wires. We will later program a microcontroller to do this by means of a relay. And this allowed us to test the Y-axis for the first time. And in the next step, more parts were designed and printed, this time to convert the X-axis. This open enclosure goes in here and is then fastened from the backside with a plate and 4 bolts. A NEMA 23 stepper motor can then be inserted and is likewise bolted in place. I left some room to install a longer, more powerful stepper in case that would turn out to be necessary. And a belt was then once again wrapped around the 2 motors on opposite sides and eventually fastened with a clamp here in the middle. The 6 stepper motors were all connected with shielded wires, and these wires were installed inside the steel tubes if possible. I did this because I expected electromagnetic interference from the high voltage generator of the plasma cutter. Throughout my many hours of testing, I've had no problems with that at all though. The current electronic setup is still experimental and not properly housed or anything. It consists of 3 stepper drivers, at the moment running 2 motors in parallel each, as well as an Arduino board. I've installed Gerbil on the board and use G-code sender to transfer a toolpath created with Fusion 360 to the Arduino board. You will see a more permanent implementation of the electronic controls in the next episode. And I only want to discuss electronics and software a couple of weeks or even months down the road, since the first solution will just not turn out to be the best way. And while this setup works just fine, I don't want to recommend anything that hasn't been tested for a good while. And speaking of a test, I have now generated a very simple tool path. A lead in for the cutter to pierce through the metal, and a simple circle. And then a lead out, returning to the homing position. Let's try it with the plasma cutter installed then. Yeah, so seeing this machine work after dreaming of a CNC plasma for so many years was frankly a redeeming and exhilarating feeling. However, there is still a lot to do here. Housing and shielding the electronics, maybe adding a water table, building a protective enclosure, adding a fume extractor and end stops, maybe automating the Z-axis to adjust the distance to the workpiece, etc, etc. And I will tackle these things in the following days. And we will see a little more of this smaller table in just a few minutes, but for now it was time to show you the work that was done in preparing the bigger table so far. These big 24 by 12 centimeter girders I bought from a friend a couple of years ago have been sitting outside for years. I'm convinced that they are still good enough for this project though. But at 4 meters long, they weigh around 135 kilograms, and let's say it took a little bit of effort to even move them around the property and closer to the workshop where I could work on them. But as luck would have it, there were 2 big holes at one end of both beams, and by mere coincidence, those holes aligned with the holes in this winch that had been sitting on the shelf for many years here as well. So I bolted that down, and it took me some time to figure out how to do this all by myself, and with unusually hot temperatures that day, it took me a good portion of that afternoon to just get these parts where I needed them to be. After brushing off the dirt superficially, I used my fine angle grinder, which we repaired in one of the earliest episodes of the Scrapyard Repair-A-Thon. I had to make a cut and then turn the girder around and make a second cut in order to really separate it into 2 sections. This entire project needed to be choreographed in just the right order. To remove rust and just make these heavy parts easier to handle, I needed to cut them. But I had to make extensive plans beforehand so that I would even know which exact length the girders need to be cut to. so that they would fit the linear guides and screws of the CNC table I wanted to build. With the shorter sections weighing only around 50 kilograms now, I was able to place them inside the barrel as well. I was also able to do this alone, but let's just say I don't recommend it for the sake of your back. With the longer sections that remained, there was no other option but to remove the rust by wire wheeling alone. To do this properly with both girders outside in the heat took several hours in itself. And here you can see some of the results on the shorter sections. In the middle, the original state, left of it, wire wheeling, and right, acid plus wire wheeling. For this project, I wasn't able to get the parts perfectly clean, but they needed to be in a state where they could be TIG welded and where the surfaces would be clean enough to be painted later on. The new CNC table will double as a normal workbench whenever it's not used for CNC work. I will simply place a large wooden plate on top and use it just like I have used this wooden bench in the middle of the shop for the past 5 years or so. I made it from OSB and spruce in the first week after moving into this place back in 2019. I don't even like OSB, and it was never meant as a permanent solution. I always wanted to build a proper workbench from steel, and now that bench is going to double as a CNC table. I downsized the old workbench by removing the casters, and it's going to serve as a temporary support during the building process of the table before it will be completely taken apart later in this video. Even though I never liked it in particular, I must say that I also feel a sense of nostalgia here. Over 300 repairs and build projects have been done on this workbench. Probably even a little more than that. Before proceeding any further, I have now placed these heavy linear guide assemblies on these beams, simply to check if everything will fit the way I had planned it to be, and I think it's looking good. The support frame of the CNC table will consist of 4 sections that will be bolted together using massive bolts that we were able to score last month. This way it will be possible to disassemble the bench into smaller parts, which will be necessary once I will have to move to another property, whenever that will be. But in order to make this possible, some additional steel parts were needed. These heavy U sections, also from the scrap, are first cut into 4 parts of the same length, and then also angled on one side. I do that in order to remove sharp corners that would be rather unpractical and dangerous. You'll see what I mean in just a minute. The 10x10 steel girders are now also cut into 4 sections of identical length. They will serve as the legs of our support structure. After removing so much of that rust, hauling everything around and cutting everything to length, as well as partially disassembling the old bench, the day had finally come to weld the parts together. During this process, I used screw clamps, an angle, and also little washers as spacers to constantly check and correct warpage and make sure that I get nice 90-degree angles in every direction. The parts were carefully tacked, the angles checked and corrected if need be over and over again before they were actually welded together. The new to me Lorch brand TIG welder we fixed in the last episode was used here all the time and running at the maximum current setting for many hours, and I'm happy to confirm that this was indeed a great score and that it works just fine. Fabricating these 2 identical weldments took me 2 entire days, by the way, but I wasn't finished yet. In order to be able to bolt the sections together, we still needed to drill a few holes, and by a few I mean 32, 16 of which needed to be drilled at this point in time. In order to accommodate the smaller size of bolts we found, these need to be 16 millimeters in diameter, which is a little more than 5/8 of an inch. The bigger ones are 20 millimeter, or a little bigger than 3/4 of an inch. And since I can't just lift these huge parts on my drill press, we will have to use the heaviest power drills that this workshop has to offer. So for this first round of holes, we will use 2 machines from my first video about East German power tools. I'm using this blue Bulgarian machine for pre-drilling to go easy on the little pilot drill bit inside the actual 16 millimeter bit. And this East German VEB Eibenstock machine will do the heavy lifting. It says up to 16 millimeters in steel on the nameplate. So yes, this has to happen 16 times in a row. I drilled a hole, then bolted the parts together. Then I drilled the next hole, put a bolt in, etc. I did this all on the ground, hoping that whoever made this floor made it really level. And while these big old machines of yesteryear might be a little too heavy for the, pardon my French, wimpy user of today, they helped me in getting her done here without even complaining. Well, and while these modern Chinesium drill bits here might look great, they actually did not last that long, and in the end I had to use 40-year-old ordinary drill bits to finish the job. And once again, this whole ordeal cost way more time than I'd like to admit. And next it was time to finally say goodbye to the old workbench for good. And what some of the long-term viewers might not realize is that I once turned these OSB panels around because they had just gotten a little too dirty on one side. I'll have to make it look good for the viewers. This is all the dirt from more than 40 episodes of the Scrapyard Repair-A-Thon. Rest assured though that none of this will be going to waste. These parts will live on in other future projects. With all this done, all I had to wait for were some unsuspecting guests to show up at the workshop so that I could ask them for a little favor. And with all this out of the way, I could finally get Ota back into the workshop and prepare all the parts necessary to turn this steel husk into an actual CNC table. That and lots of improvements to the smaller CNC Plasma table are going to happen in an upcoming episode that I'm already working on. If this is your kind of content and you can't wait for the next episode, then please give this video a thumbs up. It would mean a lot to me and would really help in keeping up my spirits. As you can tell, I'm really trying to gear up the workshop and make substantial improvements to the fabrication and manufacturing capabilities of this place. These projects require 12 and more hour days of back-breaking labor, and I'm spending money left and right at the moment to secure the future of this 10-year undertaking that I call my shop and my YouTube channel. And while I've been able to build a large and really faithful audience here on YouTube, my ad revenue that comes from YouTube is actually more and more of a joke. I need your help and support in doing this and preparing for the next 10 years. If you can, please make a donation via PayPal. Links for that are under the video. Or become a supporter on Patreon under patreon.com/tpai. See you soon.